Hello, so today we're going to be talking about the theorems that relate to polynomial equations. And so a couple of things. We've been finding the roots of polynomial equations by factoring. And then given one of the roots, I actually showed you how to find additional roots using synthetic and long division. But today we're going to be talking about how could we find the actual factors that could be possible roots of the equation. So we're going to use something called the rational root theorem. But first, let's remember that we're going to be finding all the roots, which other names for that could be solutions, zeros, and x-intercepts. Okay? But in order to understand the rational root theorem, we really have to know what a rational number is. It is something we learned back in chapter 1, but you guys still sometimes forget what all those rules and vocabulary words are. Well, rational numbers are any numbers that can be written as a fraction, meaning p over q. And p and q are both integers, so whole, positive, or negative numbers. So rational numbers, like examples of rational numbers would be like 1/2, -7, 232 over 2. Those are all rational numbers. Irrational numbers are non-terminating, non-repeating decimals. So we don't write them as fractions. Those are going to be like our square roots that aren't perfect squares, like √2, √3, √7. You may remember pi is irrational because it's non-terminating and non-repeating. And that non-repeating is important, okay? Because like 2/3, if I write that as a decimal, 2/3 is going to be 0.6 repeating. And 1/3 is going to give me 0.3 repeating. Those are rational numbers. I can write 0.6 repeating as 2/3. So that's the big thing you need to know about irrational numbers. All right, so one way for us to find rational zeros is to use the methods we've been learning by factoring. So if I want to find the zero for a quadratic equation, I can try to solve by factoring. So that means guess and check. Look for factors of -10 that add to 3. So I think you hopefully are seeing that it's +5 and -2. And then we set each factor equal to 0 to get the roots. So we get x equals -5, which is a rational number, and then x equals 2, which is a rational number. If it has an irrational root, it's a different type of answer. It's a number that it's very hard to find the exact x-intercept on the graph, and it could be imaginary, which doesn't have an x-intercept. Okay, so what do we do if a situation occurs like this? We have this 4-term polynomial, and I tried to group it, and I found that there was no way for me to group this where it would work. So we need another strategy. So we're going to use the rational root theorem to make a list of possibilities for roots. And it's just a list of possibilities. It doesn't mean they are the roots. All right, so in your book, the rational root theorem goes through a bunch of, that math vocab in a box, and it talks about if you have a polynomial with integer coefficients, meaning the numbers in front of all of the terms are integers, then there is a way for you to find all the possible rational roots. My translation to that whole box is that that if you take a factor of the constant term and a factor of the leading coefficient and you write them as a fraction and consider both the positive and negative values of them, any one of them could be a possible rational root to the polynomial. All right, so let me show you what I mean. All right, it says use the rational root theorem to list all the possible rational roots for the equation. The first thing I want to do is make sure it's in standard form. I'm going to change my thickness of my line, sorry. And it is. And then I look at the first term, so the leading coefficient and the constant. Okay, so the constant is your P, and the leading coefficient is your Q. All right, so we're going to write down all possible factors of the constant term. I'm going to call them P's. So the factors of 2 are 1 and 2. And I would like to put them in order so that I can come up with a systematic way of going through every possible number. Then I'm going to write down the factors of Q, which I hope you're seeing are 1 and 15 and 3 and 5. Okay? So those are all the possible factors of the numbers, number 15. Okay. Then we systematically write down all the numbers from part 1 over all the numbers from part 2. So we have to go each one. So I'm going to start with 1. So I'm going to write 1 over 1, which is 1, 1 over 3, 1 over 5, and 1 over 15. All right. Then I'm going to go to 2. And I'm going to put 2 over 1, 2 over 3, 2 over 5, and 2 over 15. Then I need to consider both the positive and negative values, so I'm going to put a plus, minus in front of every one of them. Okay, so this is all the possible roots to this polynomial. Well, that's a lot. I hope you're saying that to yourself, because it is. It's a lot. So now you have to look at them and decide which would be the smartest ones to choose or the easiest ones to choose and to check. Because as soon as you find one, you don't have to look for any more. You can use synthetic division to help me. So I looked at all my numbers and I was like, I don't want to use these fractions. Okay? So I'm going to try one of the whole numbers, and I usually don't always start with 1, but I might start with 1. But this case, I'm going to start with 2. So I'm going to use this one. So I'm going to start with the positive 2. All right, so I'm going to see if it's a root. I know this question just asks me to find the possible values, but I want to show you what happens. I'm going to pick 2, and then I'm going to use synthetic division. So 15, negative 32, 3, and 2. And I'm going to bring down the 15. Let me get some more room here. I'm sorry. Bring down the 15 and do 2 times 15, which gives me 30. And then make sure you add down, and we get negative 2. And then we do 2 times negative 2, which gives me negative 4. And then we add down, and that gives me negative 1. I do 2 times negative 1, which gives me a negative 2. I add down, and I get a remainder 0. So that tells me that 2 is a root. So I've got one of the roots. How do I find the other roots? I write an equation that I can factor. And remember, these coefficients help me. Because it was a polynomial of 3rd degree, my new factor is going to be 1 less than that. So 15x squared minus 2x minus 1. Okay, so if I want to find the roots, I set them equal to 0. And I solve by factoring. So I'm going to try 5x and 3x. Oh, I like this. 1 and 1. And to get a negative 2x on the inside, I think it needs to be a negative 5 and a positive 3. And I'm just going to do a quick smiley face in my head, and I did, and I checked. And so my first x root is going to be 1/5, and this negative 1/5, and this is going to be 1/3. So now I have roots of x equals 2, x equals negative 1/5, and x equals 1/3. Now look, there's 1/3, there's 1/5, and there's 2. So I could have started off with using 1/3, but again, I wanted to use the easiest one. All right, so what I want you guys to try to do, all I want you to try to do is I want you to go through the process of labeling Q and P and putting together a list of all the possible zeros, meaning the possible roots for B and C. So that's all you have to do at this point. Just put all the factors of P over all the factors of Q, go through the process of adding the plus and minus, and make your list of possibilities. And we can talk more about that on Friday. All right, enjoy your snow day.